All right, so we're going to start this lecture or this day by talking about muscle fiber types. So we've got a single topic and outcome. Basically, we're comparing and contrasting the different types of muscle fibers. Now, before we go any further, I want you to know that oftentimes you'll hear about 2 or 3, either fast or slow, or fast, intermediate, and slow. We're going to talk about it in terms of 3 types of muscle fibers, but just in case you ever come across it, they're actually 7, 8, 9. There's a little bit of debate as to how many there actually are, but some of these muscle fiber types, they're so similar that it's just easier to classify them into 2, really 3 different categories, and so that's what we're going to do. However, as we go through this, we're going to talk about slow and we're going to talk about fast, because there's one that's intermediate that's kind of a combination of both. So we're going to start by talking about slow twitch fibers. Okay, slow twitch fibers, when you think of slow twitch, think of aerobic performance, slow and steady, runners, people like me. Okay, so when it comes to these fibers, we're going to classify them in, or at least talk about their characteristics in a couple of ways. So we've got oxidative metabolism, or in other words, are they able to use oxygen? Slow twitch fibers are because they have a lot of mitochondria, a lot of capillaries, a lot of myoglobin. Okay, the capillaries get the oxygen into the muscle cell. The myoglobin gets the oxygen from the muscle cell specifically to the mitochondria, and then the mitochondria use that during the electron transport chain. When it comes to the neurons and motor units, they are really small, or relatively small. They're stimulated first because it doesn't take that much change in resting potential to have them hit threshold, but they only have a couple of fibers per neuron, or a relatively small amount. On these myosin heads of type 1 fibers, they have that ATPase enzyme. They all do, but this one is slow, and so it takes a little bit longer for cross-bridge cycling to occur. Conversely, we have fast twitch fibers. So think of big-time muscle guy or muscle weightlifters. That's the word I'm looking for. All right. So with them, and I don't know why the animations are all wonky, they're essentially the opposite. So oxidative metabolism, these muscle fibers don't use a lot of oxygen, so they have fewer mitochondria, capillaries, and myoglobin, but their neurons are bigger, their motor units are bigger, they have they have more muscle fibers per neuron. Okay, but so we don't recruit them right away. They have a higher or a less negative, more positive threshold. So it takes a little bit longer or a larger stimulus to activate them. And when it comes to their myosin, they have the ATPase enzyme, but it's a faster working one. So this leads to greater cross-bridge cycling. Okay, so fast twitch fibers can produce more force, but they don't have the ability to produce a lot of energy because they don't really rely on the electron transport chain. So when it comes to how fast cross-bridge cycling occurs, it really depends on the specific type of enzyme, and what I mean is myosin ATPase that's on the myosin head. So different muscle fiber types have a different version of that enzyme. Slow fibers have a slow enzyme, fast fibers have a fast enzyme. The faster we can break down ATP, the more cross-bridge cycling we can have, that sort of thing, more force production. So I want you to take a minute, and I'm not going to pause it, and I want you to pause it and look at this picture, but what are some things that you see that are different between these sets of motor units here? Okay, so notice on the top we've got fast glycolytic, which are also known as type 2X. We've got the fast oxidative glycolytic, which are type 2A, and then we've got the slow fibers, which are type 1. Okay, type 2A is basically a combination of a 1 and 2X. So what are some differences you see between these fibers? Okay, so if you haven't looked or you need some more time, just pause. So there's like 4 or 5 different things that we can see here. So the bigger the motor unit, so type 2X has many more fibers per neuron. Okay, so we've got 6 here, we've got 4 here, and we've got 2 here. Okay, look at their rate of fatigue. So they produce maximal force really quickly, but then they can't hold it for very long. Okay, fatigue resistance, they produce max force or close to max force. They can hold it for a while, but over a long period of time, they're pretty tired. And then we've got type 1 that they'll just give their all for forever. Okay, Next, we've got kind of the twitch, all right? So notice very little force and a slow contraction. We have more force and a little faster of a contraction, and then we have even more force and a slightly faster contraction. So we've got contraction speed, contraction force, fatigability, motor units, number of muscle fibers per motor unit. And so we can put this together in this table here to give you an idea of what's different and what's the same. The one thing I'll mention, just because we haven't talked about it, is the fiber color. Notice that type 1 and type 2A are red, type 2X is white. And the reason that they're red is because they have lots of myoglobin, which isn't shown on this here, but they use, type 1, type 2A use a lot of oxygen. Myoglobin helps. Myoglobin is the muscle version of hemoglobin. And so those fibers are red or dark, whereas type 2X is white. This is why chicken, if you eat chicken, you've got white meat and dark meat. The dark meat, okay, so thighs and legs, they produce more force, they're dark. Okay, whereas the breast and the wings, they don't produce as much force, and so that's white meat. The more you know, right? So, are you able to do these three things? Just give me characteristics of type 1, type 2A, and type 2X muscle fibers.